So we are going to discuss about briefly what happens in the logistic regression, and at the same time we'll quickly go through one of the Python codes as well. So logistic regression is a classification technique, and that is nothing but suppose I am having a record and I wanted to predict whether something will happen or not. For example, let's say I'm applying for a loan. What is the probability that I will get a loan? Right? So that is what I want to predict based on various conditions, my gender, my age, my credit score, my income, and so on. So I'm predicting whether something will happen or not based on certain features. It's also known as supervised machine learning technique. The reason is I can break the data into train and test, split the data into train and test, because every record which we have has the responses with that also. That means I am dealing with my historical data where I know that my customer got the loan or not. And based on that, I'll go ahead and I will split it into two parts, train and test, and we'll proceed and do the predictions on that. So it is considered to be the supervised machine learning technique. Obviously, the reason is we have the entire data set. This is my data set on which I am going to train the model, and this will be broken down into two. One is your training data set, and second is testing data set. I'll create the model using the training data set. Once the model is ready, I will pass this testing data set in the model, and I will get some predictions, and that predictions will be compared with the original values which we have. And if predictions are coming correct, for example, here the actual value is my customer did not get the loan, get the loan, did not get the loan, did not get the loan, get the loan. So these are the 5 records. I already have the answers with me, and let's say my model is saying that 0, 0, 1, 1, 1. So first record is correctly classified, second is wrongly classified, third, fourth is wrongly classified, and fifth is correctly classified. So out of 1, 2, 3, 4, 5, only 2 records are correctly classified out of 5. So in that case, my accuracy is coming out to be 40%. So that is how we can check the accuracy as well. So accuracy is nothing but how many points are correctly classified upon the total number of records. Right? So that will help us to basically go ahead and understand the accuracy of the model. This is one of the accuracy measures. We have another accuracy measures as well, like confusion matrix and all those other stuff. But as of now, we are not discussing that. Now, every algorithm which we are running in the machine learning, all the algorithm has some of the assumptions. And logistic regression is also having one of the assumptions, which is very much, it should, that type of assumption should be there, else logistic regression will not work well. So the assumption which we have is the data should be linearly separable. That is the assumption which we have. That means if you see here, let's say these are my customers who are happy customers. These are my customers who are not happy customers. You can see the data is almost linearly separable. Obviously, there is one unhappy customer out here as well, and there is happy customer out here as well. But you can see the data is pretty much linearly separable. That means if I ignore this line, I can very well separate the positive points and the negative points without any problem. I can easily separate them. So that's why it is saying it should be linearly separable. The data should be linearly separable. That is one of the assumptions which logistic regression has. If that assumption is not meeting, in that case, there can be a chance your prediction may not come correct. There can be a wrong predictions. And if this assumption is meeting, then the chances are very high that your prediction will be a good prediction. Right? So that is the assumption which you are making. And what is the intention? What is the aim of the model? The aim of the model is to find a line which best separates the positives and the negatives. That is the whole idea. That I want to separate the positives and negatives. And for that, I want to create one line. It can be a plane also, depends on how many dimensions you are dealing with. As of now, it's a two-dimensional space. We can understand two-dimension space only as a human. So here we are separating the positives and negatives, and this line is separating that. This line is basically helping me to separate the positives and negatives. So here you can see that what is my task? My task is to find the equation of a line or a plane, which will best separate the positive and the negatives. That is the whole idea. So that is the mathematical equation which you have to solve. Where you can say it's a optimization problem which you have to solve. So here you can see, again, there are some mathematical concepts. There are some linear algebra concepts which you should have idea. As of now, I am not discussing that because we have a time constraint out here. But one of the mathematical properties which we have is if there is a plane which is pi and this is my vector w which is perpendicular to this plane pi, any point which is in the direction of w, and if I want to find the distance, for example, let's say this point, I want to find this distance. This distance will be a positive distance because this is the angle it is making, which is the theta, which is cos theta. And when cos theta is less than 90 degree, it's a positive value. And for example, this point here, the cos theta is more than 90 degree. It's a negative value. So basically, if I want to find the distance of this point from the plane, this distance will always be positive. And if I want to find the distance of this point with the plane, this distance will always be negative. Also, when we are talking about the logistic regression will always help me. Like when we are working on the logistic regression, the idea is that I can derive the logistic regression not only using geometry, I can derive that using probability as well, and I can derive that using the loss function as well. As of now, in this particular discussion, we are deriving the entire logistic regression using the geometry. And when we are deriving the logistic regression using the geometry, then again, this point we should be remember that if you are a positive point, you are +1, and if you are a negative point, you are -1. Now, what I will do, I will calculate the yi, which is we already know. It's +1 for positive points, -1 for negative points, multiply by W transpose Xi, where W transpose Xi is nothing but this distance. As I mentioned, there is some linear algebra concept which you will derive. You will get this formula where I am assuming that W is the unit vector. So Di will be W transpose Xi. So that is that distance, which is positive for the points at this side and negative for points at this side. So let's calculate the YIW transpose XI for this guy. the yi w transpose xi for this guy will be positive because the distance is positive and you are also a positive point. So positive into positive will become positive. What about this guy? The distance is negative and you are also negative. Yi is negative. So negative into negative will become again positive. What about this guy? The distance is positive, but the point is negative. So yi w transpose xi is less than 0. And what about this point? Same goes here as well. The distance is negative, but the point is positive. So negative into positive is coming out to be negative. So from here, what we are understanding is that if the point is correctly classified, the yi w transpose xi is more than 0 for all the points which are correctly classified. But for the points which are incorrectly classified, the yi w transpose xi is less than 0. So my requirement is that I want to create a plane pi which will maximize yi w transpose xi. Because when yi w transpose xi is maximized, that means there are more number of correct classifications. And when it is minimized, obviously there are more number of incorrect classifications. So that is my mathematical optimization problem, which you can see in the next slide. I want to find the w because see, I cannot change xi and yi. Xi and yi are my data points, the training data set. The only thing which is in my hand is the w, the coefficient, the weights. At the end, what we are doing, we are creating the equation of a line. Y is equal to mx plus c, where this m is I am denoting as w. So I want to adjust this m or a w to create a plane which will best separates the positives or negatives. I can obviously create a plane like this also. I can create a line like this also. I can create a line like this also. But this is the best because this is giving me the good accuracy. This is giving me the correct, more number of correct classifications. So my intention is to find the W which will maximize this entire term, because when it is maximizing this entire term, automatically what will happen? It will help me to do the more number of correct classifications. So that is the idea of logistic regression. Now, there is a problem with this approach. The problem with this approach is, let's try to understand. Let's take scenario number 1 and scenario number 2. Suppose we are having one red point at the top, and these are the red points, which are negative points basically. And we have these green points. Same data we'll find here also. Scenario number 2. The data is exactly the same. Now I am creating two planes. I wanted to know which plane is the best plane. The first plane is like this, where W is in this direction. And second plane is like this, where W is in this direction. Right? Now, which one is giving me the more number of correct classification? Obviously, these are giving me the more number of correct classification. The first one. Because here you can see that W at this direction, that means any point which is at this direction are positive. Positive and positive is positive, 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 positive. Let's say this distance is 1 and this distance is -1. And let's say this distance is plus 20 because you are very far from the plane. So let's say it's very far. So if I do the calculation, W transpose xi into y, it will be +1, +1, +1, +1, +1. And then this is also +1, right? -1 into the direction is opposite, point is negative. So +1, +1, +1, +1. plus 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. But what about this guy? This guy is 20 into minus 1 is minus 20. So this is becoming minus 20. And when I sum it up, it is gonna give me minus 10. That means summation of yi w transpose xi is coming out to be minus 10. And what was my intention? My intention was to maximize this guy. But here I am getting very high negative number. I'm not able to maximize that. And why that is happening? Because of this guy, which is nothing but your outlier. What about this? Let's say this distance is 1, this distance is 2, this distance is 3, this distance is 4, and this distance is 5. And let's say this distance is minus 1. So 1 into 1 is 1, 1 into 2 is 2, 3, 4, 5. Minus 1 into 1 is minus 1, minus 1 into 2 is minus 2. So let me add it up. 1 plus 2 plus 3 plus 4 plus 5, minus 1, minus 2, minus 3, minus 4, minus 5, plus 1, this guy. Minus 1 into minus 1 is plus 1. Because you are a red point, it's a minus 1. And distance is also minus 1. So minus 1 into minus 1 is plus 1. So this and this will cancel out. I left with 1. So summation of yi w transpose xi is equal to 1, which is higher than this guy. So as per the mathematical optimization problem, this plane is better than this plane. However, if you see logically, this plane is better than this plane. 10 points are correctly classified out of 11. 6 points are correctly classified out of 11. So straight away, this plane is not looking good. But mathematically, as per the optimization problem, which we have found out, we are seeing that this is better. And that is the problem with this entire approach, because when there is an outlier, this equation which we got will not work well. And in the Python, there is a package called scikit-learn. In scikit-learn, there is a model called logistic regression. In that, the idea is they implemented this equation only. That means if you are finding the outliers in your data set, your prediction may go wrong. There can be a chance that your prediction will not be very much accurate. So in the scikit-learn, they did not implement the solution for the same, but there is a algorithms like support vector machine and so on, which can help you to basically solve this problem. Now, how to solve this problem? How can we proceed further and solve this problem of outlier? So they have come up with the idea called sigmoid function. This is my sigmoid function, 1 upon 1 plus e raised to power minus x. So they told that, okay, rather than me saying, I want to find the best w, which will maximize summation of I is equal to 1 to n yi w transpose xi. Let me apply one function on top of this equation. And what is that function? That function is nothing but sigmoid function. So they say that, okay, now my updated equation will become, I want to maximize summation of I is equal to 1 to n 1 upon 1 plus e raised to power minus yi w transpose xi. This is my new updated equation. Now, what is the benefit of this? The benefit is basically, this is my sigmoid function. This is how the sigmoid function looks like. This is my x-axis and this is my y-axis, where this is nothing but yi w transpose xi, and this is nothing but 1 upon 1 plus e raised to power minus yi w transpose xi. So it is saying that when you are increasing, I will also increase. But after a certain point, I will taper off. And if you are decreasing, I will also decrease. After a certain point, I will taper off. That means if I come back to this example, if you are increasing the distance, I will increase. But as you are applying the sigmoid function, I will not increase fully. I will taper off. It varies from 0 to 1. So I will not increase. So this is what increasing. This is what increasing. So I will not increase full. I will just go up till that point, and after that I will just taper off. So if I apply the tapering off here, this minus 20 will become only minus 1. And this minus 20 will become minus 1. What will happen? This entire thing will become 9. So automatically the outlier is taken care of. So that is the idea of sigmoid function. And why they apply a sigmoid function? Can I apply some other function as well? The answer is yes. Absolutely, you can apply the other function also. No issues. But they went with the sigmoid function because of two reasons. First is obviously the sigmoid function is a differentiable function. So your function should be differentiable if you're applying the machine learning concepts on top of that. And second is it is giving me a nice probabilistic interpretation. It is giving me a nice probabilistic interpretation. Now, what does that mean? It means that the values of the sigmoid function vary from from 0 to 1, right? That is what it is. From 0 to 1. So suppose there is a plane pi and one point W is in this direction. One point is present here. The distance is very far. So the chances of this point to be a positive point, the probability is very high. So when your distance is very high positive, the probability of success is 1. Suppose the point is on the plane. That means the distance is 0. In that case, the probability of success is 50-50. And if the point is in the opposite direction, negative. So it's very negative high distance. So chances of success is 0. The chances of you to be positive is 0. Right? So that's why it's giving me a nice probabilistic interpretation as well. So that is the idea. But in the scikit-learn, in the sklearn model, this sigmoid function is not implemented. But yes, it is implemented in the support vector machine, the sigmoid kernel. It is implemented there. So now what we'll do, we'll see the Python code as well, how it looks like. So here is the data set which we have, where we have the loan ID, we have the gender, the married, dependents, education, self-employed, co-applicant income, loan amount. Then there are other fields like loan amount, term, credit history, property area, and loan status. So this loan status is my Y, right, which I want to predict. Based on various features, these are the various features which we have. Suppose I am applying for a loan, they will check the credit history, the property area, the loan amount, term, loan amount, applicant income, co-applicant income, and so on. I'm checking if there are any nulls or not. If there are any nulls, I will clean that. I did that cleaning out here. Because once you are applying the model, you have to clean the data set first. Because if you are passing the junk, then output will also be the junk. So your model should get the proper data. And for that, some data cleaning is needed. If there are null values, you can very well go ahead and you can populate those null values. There is a thumb rule that only 25% of the data you can manipulate, not more than that. And if the business is more critical, in that case, we may have to reduce that 25% to lesser percent as well. Right. So here I am doing the data cleaning where I am populating the missing values. Like for example, for the gender, I am populating the missing values with a male. And why I am doing that? Because there are more number of males in my data set. So I'm going with the majority. Same goes with the married, dependents, self-employed, loan amount. In the loan amount, I am taking the median. I am taking the number median and populating the missing value, loan amount term, and the credit history. After that, I am doing some exploratory data analysis where I am trying to find out, is there any feature which is really important for me to predict whether I will get a loan or not. So here you can see that this is my gender feature. Let me just zoom out a bit. So here you can see that gender. Now gender is not very important feature for me. Straight away I can see that. Now why I am very much confident on that? The reason is you can see the blue one is people who did not get the loan and the orange one is people who got the loan. If let's say X amount of people or X amount of male got the loan, almost half did not get the loan. Same goes here also. If Y amount of female got the loan, it's almost half of the females who did not get the loan. So I cannot say that if you are a male, there is a very high chance that you will get a loan. Or if you are a female, there is a very high chance you are going to get a loan. It's almost the same ratio. It's just there are more male who applied for the loan. That doesn't mean that you are a male, you will get a higher chance to get a loan. The ratio is almost the same. That means if you are a male or female, I don't care. I can give the loan based on maybe some other criteria. So gender is not very important. Same way I did the analysis for other features as well. I wanted to show you the important feature which you can see at the bottom. Here I am creating the scatter plot. I told you that my data should be linearly separable. So when I am creating the scatter plot, you can see that the positives and negatives are not coming up linearly separable. Right? So if I proceed further, I'll show you this feature. Now this is looking good. Now what happening here is, if your credit history is 0, you're almost not getting the loan. Almost everyone are rejecting. Every record is getting rejected. However, if you see here, there are more number of conversions when the credit history is 1. So straight away, credit history is looking one of the important variables. So out of this entire exploratory data analysis, we have found out that credit history is one of the important variables. Now, once we are done with that, we'll proceed further and we will, like, basically now I'm converting the data into the numbers. Gender, I'm making male, female to 0, 1 and so on. Because again, we are going to apply the model, and in the model, we have to do a lot of mathematical calculations. So when we are doing that, we have to convert all the categorical features to the numerical features, so that we can go ahead and we can use that as well in my calculations. So that is what I'm doing with all the different category, converting the category to the numbers. After that, what I'm doing is I'm breaking the data into X and Y first of all. Because when we are running the model coming from the scikit-learn, you have to pass the train the X part, train the Y part. That means what I am doing is, suppose I am having this data where I have the loan status and all other columns. I am breaking this as X, breaking this as Y. And then after that, I am breaking this into X test, Y test, X train, Y train, or X train, Y train, X test, Y test. So that is what I am doing here. First of all, I am breaking the data into X and Y. After that, I am going ahead and I am breaking this data into train and test, where I am making my test size as 30%. Now, once that is done, I am using my testing data, sorry, the training data in the model. I am calling the scikit-learn linear model, where I am calling the logistic regression. And after that, we are calling the logistic regression model, where I am passing the X train and Y train, the training data set, which is the 70% of your data, because you gave your testing data set as 30%. So 70% of the data is getting inside the model for learning. Once that is done, I am calling the coefficient. Now, if you see here, this is the second last feature. That is nothing but your credit history. You can see all the features are very small. These are what? These are nothing but the coefficients. Y is equal to m1x1 plus m2x2 and so on. And these are the m's. These are the coefficients. These are the w's as per the equation. So you can see this is very small number, 0.003, 0.05, 0.0006, 0.01 negative 6, like that. But this one is 2.97. So I am getting the higher weightage for this particular feature. That is the second last feature. Now, what is the second last feature in the data set? You can check that. The second last feature is your credit history in your X, because this is my Y. I will not consider that feature. This is my Y. So this is my last X, which is property area, and this is my second last X, that is the credit history. So here I got straight away that yes, this is one of the important features, and the coefficient is coming high also. Right? Now, once that is done, I am going to use the test data set. Here is my test data set on which I am predicting using the model. Because the model which we have created is the log model. That is my log model. So now I am going ahead and I am basically using that model and predicting the X test, the testing data set. And in that, ypred is equal to log model dot pred X test. I am getting the predicted outcome. I also have the actual data as well. The Y test is already there with me. This is my Y test, and the prediction is stored in the ypred. So I am going to use the test, which is the actual data, and pred, which is the predicted data. I am using the accuracy score. That is your this thing, right? Performance metric. So accuracy score is coming out to be 80%. That means how many points are correctly classified upon total number of points. That is the accuracy score for you. There is one more concept called confusion matrix, which is basically you are breaking this into 4 numbers. Let's try to understand these 4 numbers. So we have 16, 1, 36, and 132. In my testing data, there are 168 records. That's why you are getting the prediction also 168. You can sum it up. 132 plus 36 plus 16 plus 1. This is going to be your 168. Now, how to read this outcome? 0, 1, 0, 1. This is my actual. This is my predicted. If I read row by row, 16 plus 36, that is coming out to be 52. 52 records are the customers who did not get the loan as per the actual data. Right? And if you read this 132 plus 1, 133 records. These are the 133 records who actually got the loan as per the actual data. And what about predictions? What about the model? What model did? 16 plus 1, 17 people did not get the loan is what my model is saying. And 132 plus 36, 168 people, they got the loan, right? That is what you're getting here, sum of y prime. Because it consists of zeros and ones. So 168 is all ones. Total number of records are 168 plus 16 plus 1. That is my total number of test records. Out of 168 got the loan is what my model is saying. 17 did not get the loan is what my model is saying. But in actual 52 did not get the loan and 133 got the loan is what the actual data is saying. So what is the accuracy? Accuracy is nothing but this plus this. Because as per the actual and prediction, 16 people did not get the loan. As per the actual and as per the prediction, 132 people got the loan. So 132 plus 16 upon 132 plus 16 plus 36 plus 1. When you do this calculation, this is coming out to be 80%. That is your confusion matrix. So confusion matrix again helping me to go ahead and understand how the accuracy is and all those things. Right? So that is the prediction which we are doing on the test data set. After that, what I did, I got the new customer. Because at the end, what is my task? At the end, my task is to go ahead and do the prediction for the future. If in the future new customer comes in, what is the probability that they will get the loan? So let's say these are my two new customers. So once I got the data, I am just doing some data cleaning and all. Like if there is a missing value, populate that, converting the data to the numbers and all those things. The basic data cleaning we have to do. And once that is done, I am passing that in the model. The model is log model, which we created on the training data set. We check the accuracy using the testing data set. And now we are predicting for the new customers, which we just got in this file. And this is the prediction which I am getting, that when it's a first record, I am going to get the loan, and second record, I am not going to get the loan. And if you remember, I told you credit history is very important. That is the very important feature we have. So here you can see that for the first record, the credit history was 1. That's why he is getting the loan. And for the second record, the credit history is 0. That's why he is not getting the loan. So now once you are done with this model building, you can create your front end where end user can pass the details. Like suppose I am the banker and I want to check whether my customer will get loan or not. I will get, let's say, the front end where I will give the details about my customer. And based on that, it will do the prediction whether my customer will get the loan or not. And based on that, I will decide how much loan should I give and all those things. So that front end solution we can create. Now, logistic regression is one of the good algorithms because it is helping me to do the interpretation. The interpretability is very good. For example, here, the first customer got the loan, the second customer did not get the loan. So I have the reason for the same. I know that the credit history for the first guy is 1, the credit history for the second guy is 0. That's the reason he is not getting the loan or he is getting the loan. Right? So the interpretability is good. And that is obviously we would like to have in the model because in some of the models, the interpretability is not there. For example, k nearest neighbor, random forest. These algorithms, the interpretability is a problem. I will not able to tell that why I am not getting the loan and why I am getting the loan using those models. To get the interpretability in that, you have to do some concept called uh, what is it, backward eliminations and all. But in the logistic regression, it is very easy for me. I can just pass the entire data set. I will get the coefficients. Whichever coefficient is higher positive, higher chances to get a loan. Whichever coefficient is having higher negative, it is making down. The chances of getting the loan is becoming down because of that. Right. So that's why the interpretability is coming out to be very good in the logistic regression. And that's why people are preferring to go with logistic regression as one of the solutions for the classification problem statement. Also in the logistic regression, if I am looking for a low latency system. Now, what is a low latency system? Low latency system is nothing but when I am passing the input to my model, the output should come faster. I don't want that my output will take time to, like, basically the prediction should take time is what I don't want. So I can actually go ahead and I can make it faster as well. Performance wise, I can make this algorithm faster as well by applying one of the concepts called L1 regularization. So there's a concept called regularization basically. The purpose of regularization is to go ahead and, like, there are two types of regularization, you can say. One is L1 regularization and second is L2 regularization. Right. L1 regularization is also known as lasso regression, and L2 regularization is also known as ridge regression. So there's a concept called L1 and L2 regularization. So let me go ahead and I'll open the scikit-learn page. And here you can see that there is a concept called penalty. Here you can see. There are three types of penalties. One is your L1, L2, and third is your elastic net. Now, L1 regularization is basically used for making the output more. Right? So when I'm looking for a faster output, in that case, I will go with the L1 regularization. And when I'm looking for a better accuracy, in that case, I can go with the L2 regularization. So it's a trade-off between the faster output and the better accuracy. As a business, what you want? As a business, what I want is, I want the faster output. In that case, I will go with the L1 regularization. As a business, what you want? I want a better accuracy. In that case, I can go with the L2 regularization. So the idea is basically, what is your requirement? Suppose you are into the internet business and you want the faster output. I don't care about the accuracy of the model. I just want my end user should get the faster output. In that case, I will go ahead and I will look for the L1 regularization. But if I go with the life sciences, healthcare, whether my patient will get disease or not, whether my patient will get cancer or not, their fast accuracy does not matter. I am looking for the better accuracy, right? I'm not looking for the fast model. So in that case, I will go ahead and I will go with L2 regularization. because L2 regularization will give me the better accuracy. Again, there is a mathematical derivation for the same, why it's giving me better accuracy and all. I'm not doing that, but I'll give you the brief idea here. So suppose I am applying the L1 regularization, and when I'm applying the L2 regularization, let's say I wanted to predict whether I will get promotion or not, right? Whether I will get promotion or not is my Y. Based on my uh, experience, based on my team size, based on my education, based on my son's age, right? Now, experience is obviously important. So that is higher importance. Team size is also important. Absolutely. Education is maybe okay, may not be okay. So let's say lesser important. Son's age is obviously not important. It's not important for me. So when I am applying the L1 regularization, it is going to give the weights to only those features which are important, and it will give the weights as 0 if it is less important or not important at all. The weight will become 0. So why it is faster? The reason is obviously, suppose a new record comes in, I have only two numbers to multiply. I have to multiply the experience of the new guy with M1. I have to multiply the team size of a new guy with M2. These two multiplications, I don't need it because it's already 0. So automatically my calculations will become faster. And that's the reason L1 is faster as a performance wise. The speed wise, basically. Right? Because your coefficients will become 0. So basically the weight, this is known as weight vector. This is known as weight vector. Your weight vector will be more sparser. That means there will be more number of zeros, right? That is the idea. That's why the performance of the model is fast. Run the speed wise, basically. But in the L2 regularization, you will get the M1, M2, M3, and M4 also. Your son's age is not important, but still I will get very small weight. Here the benefit, why the performance is good, looking good, why the model performance is good, accuracy wise, because I am giving certain weight to my education as well. Because education was little bit important. That's why I'm giving some weight. So I'm not ignoring this feature, which I wanted to use, and I'm using it. And that's why accuracy point of view, this model is better as compared to this model. Because education here, you are making it as 0 because it was less important. That's why L2 is better for the performance point of view, that is accuracy point of view. And L1 is better for the performance point of view, that is speed point of view. So based on your business requirement, you can decide which one to go for, which one not to go for. There is a combination of these two regularization as well, which is known as elastic net. Elastic net is the combination of L1 and L2 both. Right? So if you want, you can go with this type of approach as well, which is like where business is not very much sure about the accuracy plus the speed. So in that case, you may think of getting into L1 plus L2 both. Right? So that is the idea. Okay. So this is what I wanted to cover. Any doubts you have, let me know. Because this is what the time I had. I hope you got something new. At least you got the brief idea. All right. Very informative session. All right. I'll share this code. Yeah, I'll share the code with the support team, and they will share it to you. Okay. It's again 40-50 minutes. Obviously, I cannot talk about this, but it's a big mathematical concepts which we have. So normally I take 2-3 hours to talk about this, but yeah, Just bear with it, and whatever we got, just try to capitalize on that. In model, we see credit score is important, but we given it as 0 and 1. 0, 1 means credit score, 1 means better credit score, and 0 means bad credit score. It's not, as per the data, it is not giving me, the data is like that only. If you are having the actual credit score, you can pass that. But the data which I got is either 0 or 1. Cool. So thanks for your time. I'll share this file with the support team and they will share it with you guys. How can we change the career path from developer to data science? Any particular road you may have to follow? Yeah, you should have the mathematical statistical concepts understanding. You should have the Python understanding. Slowly, you have to gradually you have to go into this field. Maybe starting with data analytics, then getting into data science and so on. Scikit-learn tool is for machine learning and data pre-processing and all. Okay, Chat GPT and all also coming in. So I hope we'll have some session on Chat GPT as well, where I'll show you how to create the customized apps using Chat GPT. So things are getting good in this field of data science, machine learning, and AI. So kindly go ahead and explore that. Kickstart your career into this. That will definitely help you. Okay. I'll show you one of the Chat GPT app, right? So that you guys will get excited as well. So what I did is I connected Chat GPT with MySQL database in my local machine. And this is going to hit the MySQL database. Here is the application coming in. Now I'm connecting to MySQL database, and there, if I go and if I let me just check whether the data is there or not. Just give me a sec. DVD rental. Yeah, so there are different tables out there. Let me just call the actor table. The data is there. How many records are there? Let's check that. 200 records are there, right? So what I did is I connected ChatGPT OpenAI API with MySQL, and now I will ask as a data analyst. I will ask how many actors are there. It will hit that MySQL database. Now here I'm getting some. Okay, my API key got wrong. Give me a second. I'll just change that. So we had some time. That's why I'm showing you. Just a sec. So here I'll go and get my new API key. Right. and I'll open the chat GPT file. And here I have to replace this key because that key got expired. And now I'll just go and relaunch the app. So it will open up the app again. And now I will ask how many actors we have. So it will hit the database and it will give me the output as 200. Right? Now, if I go back to the database and let's say I'll ask about Nick, right? Show all the movies by Nick. Show all the movies by Nick. So it will hit the database and it will give me the output. So here you can see it is hitting this query. It's taking last name as you, so I have to just change that. This is the last name, Nick, right? So I'll just pass that. Let's see what happens. Here you can see I am getting all the movies by Nick. And this is the query running at the backend. I can copy this query and I can check also in the database. Here are the movies, right? So I am connecting with my own database and asking ChatGPT to give me the answer on my dataset. So all these things are coming good. All these things are very much fascinating and helping us to play around with that. So definitely we'll connect again sometime soon and we'll have a discussion on these type of applications as well. But yes, kickstart your journey. That is very important into the field of data science and machine learning and AI, and that will lead to some good returns. Okay, cool. So have a nice day, and yeah, see you again sometime sometime soon. Okay? Take care, guys.